Hey guys and gals, so you guys are going to be taking some notes through this video like you have before. When you come to class Monday, bring your notes and some knowledge to practice the skills learned here through the video. So here we go. Make sure you have Desmos.com open on your Chromebook because we're going to use that throughout. So we're going to talk about absolute value functions. We did some of this today in class or Friday in class. Using Desmos though, we're going to see some tricks that happen over time. So in Desmos, you're going to go in, type in the absolute value of x. That's all you need to type in. They have the notation down at the bottom of your screen. Now a nice little trick is if you hit that plus button at the top of the screen and then hit table and change the x column to plain old x and then the y column to the absolute value of x, you can plug in the x values required to create the y values. So on your paper, you have the x values of -3 through +3. So this table function is helpful because you can just plug in those inputs, it produces the outputs, and then you can do this on your own paper. So I'm filling in mine now, 3, 2, 1, 0, 1, 2, 3. You put them on the graph, and you'll see a V come into form, absolute value, V for value. Every time you see one, you should see a V. Now, this particular function, the absolute value of x with no extras in it, is a parent function, meaning it's like the original function of that. So that's what we're seeing there. Now as we add things in, like this one has a +3, we're going to try to see how it changes, how it moves, and things like that. And at the end, we'll kind of wrap up and talk about why things change. So we're going to x out what we have, type in the function that's there. So I think it's x, let's look, x plus 3. Again, if you want to add a table, plus and then table, change this to plain x, change the y column to the function you plugged in, x plus 3 in those brackets, and then plug in whatever x values you need, and it produces the y values for you. You can see them over on the graph as well, and then you put them on your own graph. So back into the notes we go. You got 3, 2, 1, 0, 1, 2, 3, one more time, and then they go to the graph. Again, you're seeing a V pop up. Now let's start to talk about what is different about this one in comparison to the parent function, the absolute value of x. So if we scroll back up, you guys have your paper. What's different between that function and the one we just did? You've got it. It's left 3 units. So why might that have happened? Well, there's a 3 in the function. Now I know it's a +3. If there's a plus in the brackets, it actually moves you left. If there's a minus, it moves you right, but we'll see more of that as we go through more of these. So back to Desmos. I'm going to plug in that function. We're going to use these x values to create the function. Add the table, make this plain x, turn that into the function you plugged in. You can copy and paste it down, to be honest with you. I just keep retyping it. Now plug in your x values that you want. And after a while, it actually starts to automate what the x values are. But again, we're seeing the V shape. It looks like it's shifted a little bit even more than the last one was. So we'll have to take a look at why in a minute. Just filling in our table based on what we saw on Desmos. So again, how did this function shift? Once this thing gets on the graph, you're going to want to start to think about, based on the parent function, which starts at 0, 0, how is this thing shifted? Okay, so there was the parent function. Now we're looking at this one. It seems as though we've moved 1 to the left, and 4 down. So again, we want to come back to the function itself and think about, well, what about that is making this happen? So I'm going to rewrite the function really quickly. We have a 1 and a 4 in there, and surprise, surprise, they do have a certain purpose. They're going to move it left once, they're going to move it down 4, just based on where they're placed in the function. So now we have this function. Based on what we just saw, where it was +1 made us move left 1, and -4 on the outside made us move down 4, we're going to try to piece together where this would go. So again, treating 0, 0 as kind of the starting point. How would -2 inside those brackets and +2 outside those brackets shift and change our absolute value function? So the -2 inside, that's going to move us right. The +2 on the outside, that's going to move us up. And that's where we get our new vertex. So now we're just going to plug it in here just to be safe and make sure that we've graphed it correctly. There we go, changing x to plain x, changing that to the absolute value of x minus 2 plus 2. And there's some x and y values. Now the reason that I chose 2 to be in the middle here is because since we knew it shifted twice to the right based on the notation, based on the way the function looks, that gives us an idea of where the middle of that function should be. Okay, so now we're going to put in our points just like we saw on Desmos. So again, the reason that we chose these x values is because based on the -2 inside those brackets, we should understand, hopefully at this point, that it's going to shift it left or right, and that moves it right 2 spots. So the x values are going to get moved to the right 2 spots, meaning 2 should be in the middle. Okay, so here's a couple more examples of how the parent function can change. They gave us x values this time, so we're going to go plug them in along with the function into Desmos and see what our V-shaped function will look like now that we have a 2 in front of the brackets. So again, just typing in the x values that were given to you on your paper, you should be able to produce these y values. And then we go graph. Okay, so how is this graph different from the one seen in number 2? Now, if you don't recall, number 2 was just plain old x minus 3, or maybe x plus 3 in the brackets. This one throws a 2 in front, so the shift to the left was the same. So flip back to that just to check. Now the 2 in front is going to make it steeper or more narrow as it goes up. It's not as wide. So that's what the 2 in front will do. And here we have a negative in front of the x plus 3. So I'm just going to fill in the values for you here so you can just see what happens as the video is getting a little long here. So this one was flipped. It still had the 3 unit shift to the left because of the +3 inside those brackets, but with the negative sign in front of those brackets, that makes it flip upside down. So that is why. Now here's kind of a formalized plan of every absolute value function and how it shifts based on what we just saw. So if there is some kind of addition or subtraction inside of the notation, inside of the brackets, so if it's +a or -a inside, it's going to shift left or right. This should tell you in which direction particularly. And then if we have something outside of the brackets, a plus A, and plus 2, plus 5, or minus 5, whatever, it's going to shift you up or down that many units. So if you have a plus 5, you're going up 5. If you're going, if you have a minus 2 on the outside, you're going down 2 units. And then finally, if we place something in front of those brackets, that's a multiplier. So that's either going to make it steeper or wider, depending on the number, or it's going to flip the direction. So if we throw a negative in front, it's going to flip it upside down based on where it already was. Okay? So, there's the notes. Enjoy the rest of your weekend, guys. I'll see you on Monday. Make sure you bring this so we can practice some